Okay, we're going to be working in lesson 10.2. We're going to be working on simplifying radicals. Now, we started this back in chapter 9, but we're actually going to take a little bit more in-depth look at it. So a radical expression, okay, radical just means that there's a square root involved, okay? Expression, something without an equal sign. So if you look at all of these down here, these are all radical expressions because they have a square root involved, okay? So what we're going to be working on is starting to identify which ones maybe are simplified, not simplified, and if they're not simplified, like how do we clean it up? What do we do with it? Okay, so looking at the simplified here, this guy right here. Okay, sorry guys, there we go. Looking at the simplified, okay, so if we're looking at this, this, and this, okay? The radicand, which is the number inside the radical, so 2x5, those are all radicands. Can't be broken down. So if I look at this, I can't break 5 down. X, we'll talk about variables here in a little bit, but I can't break it down. The square root of 2, I can't break it down. But if I look down here at these guys where they're not simplified, that 12, I can break the 12 down. One of the other things that you need to know about it is there's no fractions inside of a square root. So if you have fractions inside of a square root, in this chapter we'll start teaching you what do you do when that happens. Also, there can be no radical or square roots in the denominator. So here, this is not going to work out so well either. And I'll show you how to clean up something like that as well, okay? So again, simplified is what we're looking for. We're looking for no fractions in the square root. We're looking for no square roots on the bottom of a fraction, okay? And we want to make sure that nothing can be broken down. So when we come down here, now, A and B here are just kind of review of what we had already been talking about in the last chapter. And so we would start by breaking this down, and this would become 2 and 26, and then we would get 2 and 13, and then we'd pair them up and move them out. So in this case, we would get 2 radical 13 or 2 root 13. Doesn't matter if I say square root or radical, those are interchangeable. Okay, so if we go to B here, again, B is the same thing, a review from kind of what we did. I'm going to break this one down to 8 and 10, and then 8 would go to 2 and 4, 4 would go to 2 and 2, and then that 10 will go to 2 and 5. So again, we're pairing them up, right? Pair of 2s, pair of 2s. Those move out, so I have 2 times 2 or 4 on the outside. And then I have this poor little guy right here, doesn't have a buddy, so we're going to have a 5 left over on the inside. So that's kind of a brief review of what you know so far about square roots. So now we're going to move to C. So on this one, you're still going to be breaking down this 180. However, we now have a number out front, okay? It doesn't change our first step. We're still going to go ahead and break this down to like 18 and 10, and then 18 can go to 2 and 9, and then 9 can go to 3 and 3, and the 10 will go to 2 and 5. So now it still doesn't change what we do. We're still looking for pairs. Okay, I'm not circling the 9 there. I'm just circling the 2s. Okay, and then like I said, we always are looking for that one guy that's by himself. So now the difference when there's a number out front is that we're going to take that guy times our circles. So normally we would take 3 times 2 and put a 6 out here, but because there's a 2 out there, we have to take 2 times 3 times the 2 out here. So when we do that, 2 times 2 is 4, times 3 is 12. And then you still have the little leftover 5 guy hanging out there. Okay, let's try the next one. Okay, so now when we look at this, we are going to multiply. That's what this guy says. This guy says multiply. So we can only multiply other insides with other insides, okay? So like if I look over here at E, I cannot multiply this 2 by the 3 and 15. The 3 and 15 are in the inside. This 2 is on the outside. He has to stay on the outside. Okay? All right, so when I'm doing this, I'm going to go ahead and multiply these together, and I'm going to get the square root of 48. And then I'm going to go ahead and just start my breakdown. Okay? So when it says multiply, just multiply them. So I'm going to go ahead and just break it down to what I was already using to come up with 48. I'm just going to go ahead and use the 2 and 24 from here and start breaking this down. So I'm going to get 2 and 12. 2 and 6, and then that 6 will go to 2 and 3. So, oops, sorry guys, how about 2 and 3? All right, so again, I'm still going to pair up and move out, All right, so I have a 4 on the outside, and then I still have this 3 hanging out, so I'm going to have a 3 here. So again, if it says multiply, just go ahead and multiply them, and then go ahead and continue your breakdown. So now, excuse me. So in this case, I can only multiply insides with other insides. Since there's no other inside here, or sorry, no other outside number than that 2, the 2 is going to stay on the outside. Now, if you want to think of it, technically there's a 1 in front of the square root. Just like there's a 1 in front of any variable, there's a 1 in front of the square roots. So technically, we're taking 2 times 1 to get 2. And then on the inside here, I'm going to go ahead and multiply the 3 and 15 and get 45. Okay, and so now again, we're just going to be doing our breakdown here. So I'm going to use 3 and 15 since that's what I multiplied to get to it from up here. And then I'm going to go ahead and break this down 3 and 5. Pair them up, move them out. So there's a 2 out there, and then you're moving out 3 more. So 2 times 3 is 6. And then I have a 5 left over. So 6 root 5 would be my answer there. Okay, all right, so now if I'm looking at this guy, again, we're going to multiply the outsides together, and I'm going to get a 12. And then we're going to multiply the insides together and get 100. Okay, so outsides go with outsides, inside with insides. Now, in this case, we can break down the square root of 100. Hopefully, though, you know that the square root of 100 is 10. So really, it's just saying 12 times 10, or 120. Now, it's okay if you choose to do the breakdown because you should still get a 10, even if you break it down because you didn't catch that you knew what the square root of 100 was. All right, let's go ahead and go to the next page. Okay, on G, now we're going to start taking a look at what do we do with variables, okay? Now, our first step doesn't change. We still have to go ahead and break down this 40. So like 4 and 10, 4 would go to 2 and 2, and 10 would go to 2 and 5. So I'm going to pair up and move out the 2's. So I'm going to put a 2 on the outside. Now I'm going to leave some room, and I'm going to put the square root here. And then we have 2 times 5 left over on the inside, so we have a 10 left over on the inside. Okay, so now with the variables have the same rules. Pair them up, move them out. So if I'm thinking about x squared would just be x times x. So if I'm thinking about pairing them up and moving them out, when I move it out, these two x's just become 1x. There's no x's left on the inside here because there's no leftovers here. All right, let's try the next one. So now we're going to look at the y to the 5th. Okay, so I'm going to have 5 y's. Now I'm going to pair them up. 1, 2 pairs. So I have 2 pairs out here. And then we have 1 guy left over. So I have 1 guy left over on the inside. Okay, so now let's take a look at our z's. Same thing here. Pair them up. So there are 3 z's. I pair. I get 1 z on the outside, 1 pair. And then I have the poor little z left over on the inside. Okay? Rule of thumb, guys, you shouldn't have anything bigger than an exponent of 1 on these. If you've got something bigger than exponent of 1, that means you should have paired up and moved something else out. Okay, so you're either going to have none left, like the x's, there was none left, or you're going to have 1 left over. Okay, if you have more than 1 left over, then you should have had another pair. Ew, I have no idea what just happened there. Okay, there we go. All right, so H. Okay, same thing we just did. So we're going to start by breaking down that 72. So 8 times 9, 2 and 4, 2 and 2. The 9 will go to 3 and 3. So I have a pair of 2's and a pair of 3's. So those are going to move out. Now, I do have to multiply it, though, by the negative 1/2. So I have 3 times 2 is 6, times negative 1/2 will give me a negative 3 on the outside. Again, I'm going to leave some space. And then this poor little 2, he didn't have any buddies, so he's stuck on the inside. Okay, now I'm going to look at my variables. X to the 3rd. So I have 3 of them. I have 1 pair moved out, and then I have this left over on the inside. Okay, so same thing, y to the 4th. So I've got 4 y's. So I have 1, 2 pairs, so 2 pairs on the outside. No leftovers, so nothing on the inside. All right, and then z to the 7th. All right, so I got 1, 2, 3 pairs. So z to the 3rd on the outside, and then I have a z left over on the inside. Okay, so just like I taught you on the first page, you are going to multiply this. Outside stays with outsides, insides with insides. So when I look at this guy right here, I'm going to go ahead and multiply the outsides. So 2 times 3, I get a 6. And then on the inside, I'm going to take 7 times 14 here, and I end up with 98. Okay, now I have to still put my t's together though. I have a t here and a t here. So remember, side by side, you add your exponents. So keep in mind that there is technically an exponent of 1 right there. So I have got t to the third. 1 plus 2 is 3. Okay, so now we're going to go ahead and break down that 98. I'm just going to use 7 and 14 since that's what they gave us, and 7 and 2. So now the 7's pair up and move out. So on the outside there, I have a 42. I'm going to leave a little space. On the inside, I have this little 2 left over. And then now t to the third. So if I think about, I've got 1 set, and I've got 1 left over on the inside. And that's my answer. Okay. All right, J. I want you to go ahead and pause the video, and I want you to try J on your own. Okay, so let's go ahead and walk through this. So first off, you should have multiplied the outsides together and got 21. On the inside, we're going to multiply the 5 and the 20, and we're going to get 100. And then we're going to put together our variables. So I've got x and x to the 6th, or sorry, 5th. So when I add them, I get x to the 6th. Now in this case, I know what the square root of 100 is. So I know that I'm going to get a 10 here, right? And if all else fails, you can break it down to 10 and 10. 10 will pair up and move out. And then if I'm thinking about my x's, I have got 6 x's. So that means I've got 1, 2, 3 pairs. So when I move the 10s onto the outside here, I've got 21 times 10, or 210. My x's, there were x to the third. And in this case, I had nothing left on the inside. So this would be my answer. Okay, so this would be the same thing as if I put this guy with an empty square root because there was nothing left on the inside. But we don't normally write it that way. Okay, all right, last problem, example 2. A rectangle has a width of 3 radical 5 centimeters and a length of 4 root 10 centimeters. What is the area of the rectangle? All right, so area we know is length times width. So I'm going to take 3 root 5 times 4 root 10. Okay, again, I'm going to multiply my outsides together and get 12. I'm going to multiply my insides together and get 50. And now I'm going to break down. So 5 and 10, and then 5 and 2. So again, 5's pair up and move out. So 12 times 5 is 60. Oops. 60. And then I have this poor little 2 left over, so square root of 2. Now, I do expect you to label. We're talking area here, so this would be centimeters squared. All right, that concludes lesson 10-2 notes for day 1.